Today, we're going to be taking notes on two things: Dalton's law of partial pressures and the ideal gas law. So I figured I'd record this lesson for you, so that way you don't have to figure it out on your own. So the first thing you're going to do, make sure you have a piece of paper out, obviously. And we're going to title the first part of our notes, Dalton's law, partial pressure. Kind of smushed it up there. So Dalton's law is a law that's so easy, we probably shouldn't even have to write it down. Basically what Dalton's law tells us is that if we have a bunch of different gases and we add up their pressures, we can find the total pressure. Or if we know the total pressure, we can find the partial pressures of some gases. So its definition: total pressure is equal to the sum of the individual pressures. Which is just a fancy way of saying pressure total, so P total, our total pressure, is equal to P1 plus P2 dot dot dot, so however many we have, all the way until we've reached the end of our pressures. So N is just our final pressure. Alright, so if we do an example of that, our example could be written mixture has P total of 150 kPa. If our partial pressure of carbon dioxide is 10, and our partial pressure of nitrogen is 101, what is the pressure of oxygen? Okay, so it's a complicated sounding problem. It's going to be pretty easy to do if we just stick with our equation up there. We said P total right here is going to be 150. So 150 kPa is equal to all of these added up. So 10 kPa plus 101 kPa plus P02. So if we just add these up and then subtract them from 150, we know that PO2, our partial pressure of oxygen, is equal to 39 kPa. Okay. Alright, moving on. So the sub can rewind this if they need to. Just trying to get it all recorded. Moving on, our next law that we need to write down is the ideal gas law, which is going to be pretty easy. I promise this is the last gas law we're going to talk about. Alright, so the ideal gas law is PV equals nRT. So we got to figure out what those letters stand for. P, as we probably can guess, is pressure. V is volume. N is the number of moles. R is the gas constant. We'll talk about that in a second. And T is temperature. Okay, you don't need to write this next part down, but I'm going to explain it while you're copying anyways. So if we look at our equations from before, we remember that our combined gas law was P1 V1 over T1. We're going to start by writing that, and we know that that's always going to be the same number of moles, even if we change the pressure, volume, and temperature. So there's N, okay, number of moles. The problem with this is that pressure is in kPa, volume is in liters, and temperature is in Kelvin, and moles, number of moles is in moles. Just trying to see that. So if we look, we see moles is not equal to all these things, so we had to come up with a fudge factor of R to cancel out all of these other units. So when we're writing this down, there's a couple different values of R we can use based on which units we start with. switching to a separate sheet of paper. Let's see. So our R value is the gas constant. And R could be liters, atmospheres per mole Kelvin. And if we're using that one, we have 0.08206. If we're in liters, kilopascals, moles, and Kelvin, we have 8.314. And our last pressure measurement is millimeters of mercury, liters, moles, and Kelvin. And that one's 62.36. Like I said, this may seem confusing. I know a lot of you are going to freak out about these. But all we're going to do is we look at what units we have when we write out our practice problems, and then we just choose whichever one has the same units. So if our practice problem has liters and atmospheres, use this one for R. If you have liters and kilopascals, use this one. That kind of thing. Okay? So we're going to write down our sample problem, and that's going to be the end of our notes. So the sample problem is going to say 10 moles of nitrogen is held at 107 kPa in a 5-liter balloon. And we want to know what the temperature is. Okay, just like our other problems, we write down what all of our different variables are. So we have 10 moles, and we know that's N, because it's moles. We have 107 kPa. We know kilopascals is pressure. We have 5 liters, which we know is volume, because remember, like 2-liter sodas, that's how we measure volumes, that kind of thing. We know we're going to have an R, so don't forget the R, and a T. So this is PV and RT. We don't know what T is. We got to figure out which R we want to use. So if we look back to our old part of our notes for R, we know we're looking for one that has kPa and liters. So if we look up here, find the one with kPa and liters. That's this middle one. Liters, kPa, moles, Kelvin is 8.314. So 8.314 liters, kilopascals, moles, and Kelvin. Okay? Now all we have to do is put all of this into our equation. So P and V, 107 kPa, times V, 5 liters, is equal to N, R, and T. So 10 moles for N. We said R is 8.314 liters, kPa, moles, Kelvin. Just going off the side there. And finally, temperature. All we got to do is get temperature by itself. If we're multiplying, the opposite of multiplying is dividing. So divide this one and this one, and you got to do the same thing to both sides. So if we divide this side by 10 moles, we have to divide this side by 10 moles. We also want to divide by 8.314. Liters, kilopascals, moles, Kelvin. 8.314. I'm not going to write all of it out on this one. So that way, this goes away, this goes away, this goes away, this goes away. And then here's why we bothered to write out all these ridiculous units. Liters, liters, kilopascals, kilopascals, moles, moles. So that leaves us with Kelvin. So on this side, we're left with temperature. On this side, we're left with a bunch of numbers and a Kelvin, which works out because temperature is measured in Kelvin. Right? If we were to put all this in our calculator, 107 times 5, divided by 10, divided by 8.314, we would get 6.5 Kelvin would be our temperature. All right, so you guys are going to work in partners on this next worksheet. Use these notes and figure out the next worksheet. Ideal gas law is regular credit. Dalton's law is extra credit, not partial credit. All right.